Finally, inverse functions. We're asked to find the inverse function for f of x equals 2x minus 5. So I like to just think about this and say, well, what has been done to x? So it was multiplied by 2, and then I subtracted 5. So to undo that, the inverse function should add 5 and then divide by 2. So x plus 5 over 2, or I could write it as 1/2 x plus 5 halves. Either way, same thing. Now another way to find it is to say, well, this is y equals 2x minus 5, and to solve for x. So if we solve for x, we get y plus 5 equals 2x, and dividing by 2, we get y plus 5 over 2 equals x. But remember that the x and y values swap. So if I basically say, oh, that means that y equals x plus 5 over 2 is now my inverse function. Just rewriting this with y and this with x, which is what I had up here. Just to double check, I can find f composed of f inverse. What happens when I plug its inverse into itself? Well, I would get 2 times x plus 5 over 2 minus 5. But 2 times x plus 5 over 2 is just x plus 5 minus 5 is x, which is what I want because they should undo each other. I should just get out what I had originally. Number 2 asks me to determine whether x squared, square root x, x cubed, x to the 1/3, 1 over x squared, do these have inverse functions? So do they pass the horizontal line test? Because if they do, their inverse is a function. Does not pass, passes, 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 does not pass. So the check marks have inverse functions. Note that square root x, the inverse of square root x is x squared, but only this half of it. So we'd say its inverse is x squared, but only for x is greater than or equal to 0. Since this has a range of y is greater than or equal to 0, the domain of its inverse has to match the range of the original function. 3 asks us to prove that k of x equals 1 over x is its own inverse. That is, k inverse of x should also be 1 over x. Well, if so, when we compose them, we need to get x. So 1 over x is 1 times x over 1, because division by a fraction is multiplication by reciprocal, and that is just x. If I did it the opposite way, of course, I would get the same thing. It would still be 1 over x, which is x. So because I compose them both ways, I get x. They must be inverse functions. If I graph 1 over x, it looks like this. And this graph is symmetric across the line y equals x already. So when I reflect it across, I get itself. So it must be its own inverse. Composition, graphs, and algebra. Algebra, I could say, well, if y equals 1 over x, let me swap and solve. So x equals 1 over y, so yx equals 1. So y equals 1 over x. So I still get that it's its own inverse. Finally, 4 asks to determine whether f of x equals 2x plus 5 and g of x equals negative 2x minus 5 are inverse functions. So let's find f of g. Well, what do we get? We get 2 times negative 2x minus 5 plus 5, which is negative 4x minus 10 plus 5, which is negative 4x minus 5, which does not equal x. Inverse functions, when you compose them, you have to get x. So no, these are not inverse functions. The inverse of this function would be x minus 5 over 2, and the inverse of this function would be x plus 5 over negative 2. So neither one are inverses of each other, obviously.